Okay, so guys, this particular worksheet here is all about adding polynomials, multiplying polynomials, factoring polynomials. So it's a polynomial day. Okay. By the way, since I'm doing all this review, you guys might want to think about, do I have any bad tests I want to redo? Because these are great. These are great reviews to help you redo those bad tests. Okay. All right. So let's start with adding and subtracting. So when you're adding two polynomials, basically you combine all the terms that are the same. They're the same if they have the same variable in power. So I've got a 2 into the 4th there. That one's also an into the 4th. And when you combine them, all you do is you combine the coefficients. So 2 take away 5 is negative 3. So that's going to become negative 3 into the 4th. The 5n cubed, does that get combined with anything? No. So we're just going to bring that one down as is. This one, are there any squares up there? N squareds? Yeah. There is, right here. So these two can come together. A negative 3 combined with a negative 3 makes a negative 6 n squared. And then finally we have the plus 5, which doesn't have anything to combine with either. So that's how you combine like terms and add polynomials. Questions? Is that all? That's it. Okay. The next example, I believe, is subtraction. So the next odd one I'm going to do. So when you have a negative, yeah, you're going to distribute the negative first. So that's the one thing that's different when you're subtracting these things is you distribute the negative first, okay? So other than that, it's the same as the last problem. So now this 5n becomes a negative 5n. The negative 4 becomes a positive 4. The 5n cubed becomes a minus 5n cubed, etc. That's it. So that's the only difference whenever you are subtracting. After that, we're just going to combine like terms. Is there anything like the 3?
No. Yes, 4. So it becomes 7.
7.
7.
How about the n squared?
Minus 2n cubed. Oh, wait.
It gets no. Wait, there's no other n squareds, is there?
No.
Okay. So I'm just going to bring that down as is.
Oh, and then that cancels out.
No?
Oh, no. Minus 10.
So that would be negative 10, yeah?
Yeah.
Any n's? I am. There's no other n's. So that one just comes down. So I combined those. There was only 2 like terms to combine, the constants and the cubes, but the n squared and the n's didn't have any like terms. Now, John noticed and David noticed, about the order, right? So I don't know, is it possible they don't put an order? It should be in order, but I want to see what this software does because that's how your answers will look on your test. They did put them in order. So let's go ahead and put them in order. The one that has the biggest power goes first. So there you go. And they weren't in order as I did them because the way they gave it to me wasn't in order to begin with. So, but it looks like we should probably put them in order at the end. Okay. So that's adding and subtracting. I would like to do one more topic before we move into student practice, though. Okay. Are we good to move on? All right. So we're gonna do. What we're gonna do is we're gonna do all the multiplication ones on the next page, which is numbers. Not next page. Next few problems. 7 through 11. The good news is 9 and 11 are shortcuts, but 5 and 7 are a little bit more work. So these are binomials. When you're multiplying binomials, you guys, you have to use FOIL or box method, whatever you're comfortable with. I like the box myself. So 2n times 2, and now when you multiply the coefficients, so I get 4, and n times n is n squared. Now that's multiplication. That's different than what we were doing before, which was adding. 2n times negative 6 is negative 12n. Negative 1 times 2 is negative 2n. And negative 1 times negative 6 is a positive 6. And then we want to combine our like terms, right? Those are our like terms. So we have 4n squared. And we have 6, but what goes in the middle is these two things combined, right? So what's negative?
Negative 14.
There you go.
And then about the
Oh yeah, exactly, yeah. Questions? No, it's good. It's good. Good to enjoy an academic thing. It's not necessary, but it's good. Can I clear?
Yeah.
All right, next one. That's yours. There's mine. So we talked about those two a little while back, and it's the same thing. It's just it's a bigger box, right? Instead of being a 2 by 2, it's a 3 by 2, right? Rectangle, we should call it then. So the one with 3 terms is going to go along the top because there's 3 boxes going horizontally. The one with 2 terms is going to go down because there's 2 boxes vertically. And then we just do the same thing we did on the last slide. So 5x times 3x squared is going to be?
15x cubed.
Yes. And so on. I'll go ahead and just fill them in, but if you guys have a question, let me know. Good. Now you got to be careful with these ones. It's not necessarily a guarantee that they'll always be like terms diagonal from each other, but are these like terms? So we'll combine them, right? Are these like terms? Yes, so we're good. But just beware, they're not always like terms. So you got to, before you combine them, you want to make sure they are.
Wait, do you add them?
Yeah, when you're doing like terms. So the 15x cubed comes first, right? Let me explain it. But so these two are going to combine. So what would that give us, John? Good. I got confused. I got 2 people talking. That's good.
Oh, my.
No, I'm glad you both got it. That's awesome. How about this one? What would that give me if I combine those? 39? You sure?
35x. 35x.
I'm not sure, but okay, I'll take your word for it. 39. Okay. And then finally, 40. Okay. So that's that. Good. Thank you. 64 take away 25 is 39. So I just can't do that too quickly in my brain. I should. But I'm weak. All right, next one. It's yours. Okay, now 9 and 11 are special problems. We could do the box. They'll work. But I would like you guys to be familiar with the shortcuts.
Yeah, the shortcut is on that.
You just square one side.
How this one works is this is a special problem. I'll call it a special product, which means that you can use a shortcut. When you have 2 of the same thing, but one's minus, one's plus, all you do is you multiply the 2 first numbers with that, and you multiply the last 2 numbers. There you go. Much easier.
Or you just square.
Yeah. So it's a special product. Usually, the problem with that shortcut is I get a lot of kids that do that when they shouldn't. Like, for instance, if I give you this, I have a lot of students that will do this. They'll say, okay, it's a squared and 12. That's wrong. you would have to do a box. There should be something else in the middle here that we're missing, and the box will show you. But with this one, since it's a special situation, that number that would have been in the middle actually gets canceled out, so it really is just those two multiplied together. So you can only do this, huh? What? Well, if you actually did the box, you would end up with this.
Oh, because don't you just add the two?
Yeah.
And then
So the thing is here, if you add these, what do you get?
oh, zero.
Zero,
Sorry, this
right?
is
And
negative.
that's why we don't need to. So there it is. All right, so that's one type of special product.
Oh.
The other type of special product that we talked about was, what if they're exactly the same? So first of all, check this out. This is 7r plus 1 squared. I want a big mistake people make there is
They decide to multiply.
okay guys, quiet please. Almost done. Hang in there with me. John. Big mistake students make here is they just distribute this 2, and I know why. It looks like you should, but you don't actually. It means this. It means you multiply it by itself. Now this is not the same product rule as the last one because they're not opposite signs, right? But we had another special product rule for this one. Okay, ready? So, square this number. What do you get? 49 what? Squared. Square this number. What do you get? Now, the middle one, you're going to multiply these together and double it. So, what is 7r times 1? So, what is 7r times 2? There it is. So, not as simple, but it still works. Square the first, square the last, multiply those two in the middle, and double that. So 7r times 1 is 7r, doubled is 14. Okay? It's nice to know the shortcuts because sometimes problems get pretty complicated, and being able to get little things like this out of the way quickly is helpful. All right, so square, square, multiply, double.
Will you square the 1 as well?
Yep, yes you do. And when you square 1, it just stays the same. Because 1 times...
Square that one as well. Like, if it wasn't
Yep.
a 1, it would be...
Always square the first number, always square the last number. So I can give you another example if you'd like to see one. Like, let's say I had this. Let's say I had x plus 5 times x plus 5. So you would square the first term. What would that be? X squared. Square the last term. What would that be? 25. You would multiply these. What's that? And then double it. Okay. That's it. All right. So I'm going to go ahead and let you guys, but like I said, you know, if worse comes to worse and you don't want to use the shortcuts, you don't have to, because you can always just do the box. It works. It's just that shortcuts are nice. So I'm going to stop there.
This word makes me feel dumb.
All right. Let's work.
Hard.
Okay, guys, ready? We're going to talk about factoring now. Factoring. So I'm going to skip 13. I'm going to skip 13. I'll come back to that later. For now, let's take a look at 15. Just follow my lead. All right. So this is a difference of squares because I have two perfect squares that are being subtracted. So here's how this works. We're going to take the square root of that. Guys, I got too many side conversations going on out there. Henry, you're one of my main culprits here. I need to be quiet.
Oh, no. Okay.
All right. So what's the square root of 9x squared?
3x.
Okay, so you're going to put that here and here. Then you take the square root of that.
5.
And one's a plus and one's a minus. That's what we call a difference of squares method. Okay? Girls. Guys, put the phone away.
Okay.
All right. Let's move on. That's for you. I'll let you guys do that later. Let's take a look at this. Now, if I wanted to factor this,
Oh, wait.
I'm calling myself out. Okay, this is a phone.
Now, for this one, I want to factor it. When I factor this, it's going to turn into two binomials being multiplied together. But how do you do that one?
You split it up, so it'll be 3.
It's 6x.
So you're going to do the box.
Okay, so top
This one goes top left,
negative 10 goes on the bottom.
negative 10 bottom right.
Two numbers have to add up to us.
Now, this is the thing where you have to do a lot of guessing and checking here, so you probably want to have a pencil instead of a pen ready, okay?
65.
So, 2 times 3? Sure. And we want to put an X in both spots, right? And how about 10?
5
5 and 2. Now, where should I put the 2?
Up. Yeah, up.
Now, that's a good point. So, now, if this is too much information for some of you, well, it's okay, you can ignore me. But I will say that I know the 2 wouldn't go here because I know that when you do these, there shouldn't be any common factors between these two. Okay, that can save you some time. But if that's too much information for you to hold on to, don't worry about it. You can still figure it out just doing guess and check. But here we go. 2x times 2 is 5 times 3 is, and these two need to be combined to make the middle. If they don't, something's wrong. Now, in this case, they can make negative 11 if the 5 is negative. Because a negative 15 combined with a positive 4 would make negative 11. So, that's it for that one. So, we've learned about difference of squares. And we've also learned about the box method is what you use for polynomials with 3 terms. Okay?
Oh, I also need help with
Are we good?
And then 19 is pretty much the same thing.
It is? Oh, okay.
that. Are we going back to 13?
Not yet.
I didn't say nothing.
There you go.
She did help me with the
Oh, yeah.
cycle.
Yeah, during student practice, I'll come help you out. Yeah, whatever you need. Okay, so let's take a look at 19. Now, number 19 has 4 terms. What strategy do we use for that?
You're gonna
Box
plug
again.
all 4 into
But that's the only difference. When you have all 4 terms, instead of just putting the first one in the top left, the last one in the bottom right, when you have all 4, basically you put all 4 in there, okay? So, but the first term still goes in the top left, and the last term still goes in the bottom right. The other two, it doesn't really matter where you put them, just so long as you put them in there. Now, for this one, yeah, I wouldn't do guessing and checking, okay?
Oh,
You could, it's just that it would be unnecessary. You can actually just get the answer right away by taking out what each row and column has in common. We couldn't do that with this one because we only had 2 of the boxes filled in. And that's why there's so much uncertainty involved. But here, we can figure it out right away. For instance, to figure out what goes here, I just need to look in this row, this column here. What do they have in common? I can take out an X. I can look in this row. What divides into both of these? 3. And what divides into both of these?
2x.
2 and an X.
And then 7.
And then 7. So there's no guesswork when you have 4 terms. So it's actually easier. These guys over here, since you only start with limited information, there's a lot of guessing and checking you have to do. So for this one, the answer is x plus 3
oh.
and 2x plus 7. Good. We're getting there.
There's no reason you should have homework.
Okay. I think,
Isn't it x squared?
hold on a second. I want to peek at what's up here. All right. So for the next few problems, I may not do all of them, but I'll do some, okay? I'm going to review it, but basically what you do is you always start by taking out a greatest common factor, And then if there's two terms, use difference of squares. If there's three terms or more, use the box.
You can
Okay?
take an X out of all of them.
So sometimes the past two problems I just did, we just had to factor once, right? It was difference of squares, or it was box, and we were done. But that's not how it necessarily goes. Sometimes you need to factor it once, and then you take those two answers, and one of those can be factored again. So I'm going to show you a few different problems, okay? Yeah.
Isn't this, I'm going to probably sound stupid enough, isn't this the like GCF method?
Yep. So let's do it. So the first thing that we're going to do here is we're going to start by taking out a greatest common factor.
Oh,
We went back to 13, yes. So I could take out more than x. I could take out more than 2x.
2x
Squared.
I could take out 2x squared. All these numbers can be divided by 2, and all of the terms have at least x to the second power in it. So I can take out a 2x squared. You want to take out the most you can. So if I divide all three of these by 2x squared, let's see what we have left. 4 divided by 2 is 2, and x to the fourth divided by x squared would be?
X squared.
Good. 8 divided by 2 is 4. X cubed divided by x squared is x. This is interesting. What am I going to have over there?
0. 1.
Because what's 2 divided by 2?
Oh, 1.
1. And x squared divided by x squared is 1. So, there you go. Now, we're not done, though. That was a GCF. Now we do the what? The box. It's just more work. So 2x squared goes here, negative 1 goes here. Since there's three terms, that's all I put in it. And now we start working. So let's try 2x and 1x. 1 and 1. Uh-oh. I'm feeling uncomfortable. Well, that's not possible, though, because we need 1 here. So really, there's only one way this is going to happen. Now, it wouldn't matter if I switched these. It still won't work, right? So I just realized I goofed. I didn't goof. It's fine. This is what you would do. But this is not going to factor, so we're done. Not factorable. But technically, you should check for that. So this is our final answer. I thought this was a multi-step factoring problem, and it's not. It's just a GCF, and you're done. I goofed. I just didn't realize it because I couldn't do that in my head. But now I see that, oh, that's not factorable, so we're done. Yeah, but I did it like last week, so I'm not. All right, so there's that. Let's do one that does actually have a few steps to it, though, because I know the next ones do. And the way I know that is because the directions changed a little bit. Instead of saying factor, it says what? It says factor it completely. When you see that, chances are you're going to factor it more than once. Okay? So here we go. What method would I, first of all, is there a GCF here? So let's skip that. Is this a, now what method would I use here? That's a difference of squares.
It's going to be x squared minus 9x squared plus 5. And then you can do the
So you square root that, right? You get that. Then you square root this, which is?
minus 9 and then plus.
You got it.
Yeah, but only negative.
Only this one, right? So we could do another difference of squares to this one because it's a minus. This is not a difference of squares, so you can't do it again. Okay? So we square root that.
This one's actually x squared minus 3x.
Close.
Plus 3.
What's x? What's the square root of x squared?
X.
It's x. Square root of 9.
3.
Now, can we do anything else with this? How about this? And we already said that's done, so now we're done. But the point is sometimes you have to factor more than once to factor it completely. Okay?
It's more of a
For some people. Some people like factoring and polynomials. Some people like graphing more, etc. We all have our different strengths. Yeah, you were doing really good yesterday. And so today, so what you want to do is be thankful for the ones that suck.
Isn't it what?
Because the ones that you're good at, you already
So is it x squared?
be thankful for the hard ones so you're ready for your final, huh?
Is it x squared minus 9x squared plus 9?
That was the first step. Did you miss the rest of it? Yeah. So then you do it again to this one.
Oh yeah.
Okay. Okay, let's move on to another one. All right, fun times. Here we go.
23.
Oh, that's yours, huh?
Yes.
All right, well, whatever. Here we go. GCF? Got a GCF there, don't we? So we're going to take out a GCF, and this is what we'd be left with. What method would I use here? Now, if you don't mind, I'm going to kind of try to go through the box stuff a little bit quicker now because we've already reviewed that. I just want to demonstrate the fact that, yes, sometimes you have to factor more than once now. So, but if you got a question, feel free to ask me. Can either one of these, I'm sorry, just a second. Can either one of those be factored? We're done. So question? Yes, that's a -2 there. Yeah. I'll leave it. Oh, cool. Yeah, so the rest of the time in class is for your guys is to finish up your worksheet, whatever you want. Of course I can. Sure. Did you need the bathroom? Or you have a question about math? Okay. Let me